That you're going to be learning. There's the product rule, in which you're going to add the exponents. The quotient rule, you'll be subtracting the exponents. The power rule, you'll be multiplying the exponents. And then you have the zero rule and the negative exponent rule. Now in this lesson, we're going to specifically focus on the product rule, using the product rule of exponents. We're also going to identify what the coefficient of a monomial is, and then to simplify expressions using the product rule for exponents. The product rule of exponents. Product rule for exponents. When multiplying powers with the same base, the rule is keep the base and add the exponents. So in this example, we have b raised to the m power times b raised to the n power. Notice that we have these two terms that are being multiplied, that they have the same base. So if the base is the same, keep that base. In this case, the base is b, and then simply add their exponents together. Let's do an example, and it'll make more sense. Example 1. Notice you have x raised to the 4th power times x raised to the 3rd power. The base is the same, the base is x. So we're going to keep that x, and then we're going to add their exponents of 4 plus 3, which is going to give us an answer of x to the 7th power. In example 2, you have d times d to the 5th. Anytime you see a variable or a term that do not have an exponent, it is implied that it has an exponent of 1. So here our base is the same of d. Keep the base of d and add their exponents. That's 1 plus 5, which is going to give you d to the 6th power. Next, we have 3 terms that are being multiplied, and all 3 terms have the same base. So we're going to keep that base of b and add their exponents, which is going to give us b to the 17th power. It doesn't matter whether it's a variable or a number. If you're multiplying terms and their bases are the same, the rule is keep the base. In this case, the base is 5. I'm going to add their exponents of 2 plus 7, which is going to give me 5 to the 9th power. Now note, I'm just simply illustrating the rule. However, if you had something like that last example on the test, you would have to go ahead and multiply it out. In other words, you're going to have to evaluate that and raise 5 to the 9th power to get the answer. So, product rule of exponents. Now I want to identify what the coefficient is. So when you hear me talk about coefficient, I want you to understand what am I talking about. The coefficient is the numerical factor of a term. So if you have a term, think of it as it is simply the number part of the term. Again, the number part, the numerical factor. So for example, in the first term of negative 5, m to the 3rd power, the number part of this term is simply negative 5. So that term has a coefficient of negative 5. How about the second term? And by the way, these are all monomials. Monomial is a cluster of one term. So what is the coefficient of this monomial? Again, remember, it is the number part. So the only number I see here is 2.5, and that is my coefficient. In the third example, you have negative x, y to the 4th power. Again, keep in mind in algebra that we don't place whenever you see a variable with no number in front, it is understood to be a 1. We just don't write the 1 there, but you know it's implied. So because this is negative, that means that this term is going to have a negative coefficient of -1, a coefficient of -1. Let's go to the next one. We have 7. It's a number part of it. I only see just that one number, and that's 7, so that is my coefficient. Let's take a look at the last example. Maybe a little tricky. Don't let fractions scare you. Think of number part. Number part, it has nothing to do with the variables. What do you think the coefficient of that term would be? Okay, so recall what I said, that variables, if you don't see a number out in front, it is understood what number is there. Yes, it is assumed to be a 1. So we have a 1 on top, and on the bottom I have a number of 9, so the coefficient is 1/9. Again, coefficient is the number or the numerical part of a term. And now that you know what a coefficient is, let's go ahead and multiply some group of monomials. So step 1 is to multiply their coefficients, and then step 2 is to use the product rule for exponents that have like bases. So let's do example 1. Step 1, multiply the coefficients. So the coefficient -2 times the coefficient of 4 is going to give me a coefficient of -8. Now let's see what's going to go behind that -8. Let's start with our variables. We write them in ABC order. So starting with m, for the first term I have 1m. Second term I have a total of 2 m's. Keep the base of m, add those two together. 1 plus 2 is going to give me m to the 3rd power. For the n's, I have a total of 2 n's. That's going to be n squared when we add them together. So the answer to number 1 then would be -8 m cubed n squared. Let's go to number 2. Step 1, multiply the coefficients. -3 times -2, a negative and a negative. That's going to give me a coefficient of +6. Next, what goes behind that +6? Let's add our u's. That's going to be u to the 1 plus 3 is 4. So u to the 4th power. Let's add our v's. 2 plus 1. And that's going to be v to the 3rd power, which is going to give us 6 u to the 4th power, v to the 3rd power. Number 3, let's multiply our coefficients. 9 times 9 is 81. Now let's see what goes behind the 81. Let's add our x's. 1 plus 2 is going to give me x to the 3rd power. Let's add our y's. Again, 1 plus 2 is going to give us 3. So our final answer is 81 x cubed y cubed. Next we have the last example, a coefficient of 5 times the coefficient of -8. That's going to give me -40. Now let's see what goes behind that -40 in ABC order. Adding our a's, 1 plus 2, we're going to have 3 a's. For the b's, 2 plus 3, we're going to have 5 b's. Let's add our c's, 1 plus 5, and we're going to have 6 c's. So our final answer is -40, a cubed, b to the 5th power, c to the 6th power. Simplifying expressions.